Hi there, this is Shaman and you're watching the Genesis YouTube channel. Today we will see a question in which we have to find the angular velocity of the velocity vector itself. The problem goes like this. A small stone is thrown horizontally with speed u from a height h at the instant t is equal to 0. Assume heights and distances involved to be very small as compared to the radius of Earth. What is the angular velocity with which the stone's velocity vector rotates at time t? I suggest you pause the video and try this question on your own. This is not a very difficult question, but you need to be crystal clear on the vector nature of velocity and the components of acceleration and what are their significances. This is the answer. We now go ahead with the solution. The figure shows the situation at time t. The stone was thrown from this position and now it is at this position. Its horizontal velocity has remained u, whereas it has gained a vertical velocity gt. Suppose the angle that the velocity vector makes with the horizontal is phi. The speed at this instant will be the magnitude of velocity, which is obviously root under u square plus g square t square. What we want is this d phi by dt, which I am writing as omega v, omega of the velocity. The rate at which this velocity vector turns is the rate at which this angle phi changes. This is the significance of the angular velocity of the velocity vector. To find this angular velocity, let us consider how this velocity vector changes in a time dt. Look at this figure. This figure shows the turning of the velocity in time dt. This is the initial velocity, and finally this shows the final velocity. Now you can see that this part is actually the change in velocity vector, which is dv vector. Now in this time the velocity vector has turned by a small angle d phi. Now visualize a small arc like this having magnitude same as magnitude of v vector, cutting it like this. So this extra length is the change in magnitude. This extra length is the change in magnitude of the velocity vector. So this is the change due to the magnitude of the velocity vector, and this one is the change due to rotation of the velocity vector. So what is the length of this part? It is very easy to see that it is nothing but v into d phi. So the magnitude of the change in velocity vector just due to turning of the velocity vector is v d phi. Now this change in magnitude of the velocity vector, this is responsible for tangential acceleration. Then what is this responsible for? Obviously, this is responsible for the normal acceleration. Hence, the normal acceleration is the acceleration due to the change in direction of velocity vector. Tangential one is the change due to change in its magnitude. Since the magnitude of the change due to changing of velocity vector's direction is v d phi, the rate of change is v d phi by dt, and this is nothing but the normal acceleration, magnitude of the normal acceleration, a normal. Can we equate it to something? To find the normal acceleration, consider this figure. The total acceleration of the stone is constant, which is g, and this is the tangent direction, which is along the velocity, and perpendicular to it is the direction of the normal. What is the component of this total acceleration along the normal? It is g cos phi. So the normal acceleration can be written as g cos phi. The normal acceleration can also be written as v d phi by dt. Therefore, we can equate these two. I am writing d phi by dt as omega v. So this term becomes omega v into velocity. is equal to g cos phi. Now look at this triangle. In this triangle, you can clearly see cos phi is equal to u by v. So we substitute this, and the value of v we know from here. So from this equation, we can get the omega v as ug by u square plus g square t square. This is your final answer. This was again not a very difficult question, but it involved clear concepts about what the acceleration components of a particle are and what are they due to. One component of acceleration changes the direction of velocity, the other component changes the magnitude. The one that changes the direction is the normal acceleration, and the one that changes its magnitude is the tangential acceleration. If you learned something from this, like, subscribe, and share widely amongst your friends. And as always, till the next time, stay safe and stay healthy, you all.